Okay, here we go with another module, module number 8, network optimization. We are almost done. After this, we'll have 2 more sessions. This is all about network optimization broken down into 2 small lessons. The second one now should be pretty obvious that VMware will cover ESX top once again. So a refresher of the networking concepts and best practices for optimization. Remembering that everything in VMware is all software based, we're going to have some latency. From the guest OS has its own input-output stack. The data that's going to leave has to go through the virtual NIC driver, then goes to the virtual NIC device, goes through the VM kernel, through the virtual input-output stack, and then out the physical NIC. All of that process can have latency and cause issues with getting data in and out quickly, as you would expect in a normal network. Ideally, you should be using VMX network adapters. They are para-virtualized device drivers. They are specially built for VMware. They share a buffer between the virtual NIC driver and the virtual NIC device. They offload some of the calculations to the hardware to do. That way it doesn't slow down the whole processing. There are currently 3 versions. Of course, VNX 3 is the one that is more favorable to use in virtual machines, but you do have all of these options as virtual network adapters. The VMX Net3 driver, like I said, is optimized for VMware. It can use reserved memory to increase the ability to move packets through the operating system. So that whenever you reserve RAM for a VM, some of it will be used for networking. By default, every network transmission uses a single thread. It is possible, especially if you're going to use a lot of communication, that you use multiple threads. The way to do this is actually in the advanced settings. So you would go under configure. You could search for a .NET VMX type. 1, again, is the default. And you can take that all the way up to 8. That way you have a higher transmission rate and multiple simultaneous TCP streams. Your virtual switch is already optimized for specific caching techniques. So there's not a lot to do with a switch, as you have seen working with the standards and distributed switches. They're already optimized to handle all kinds of traffic. There is a segmentation offload to improve networking performance by reducing the CPU overhead. So it takes large packets, and those will be offloaded to the adapter for further segmentation. It can divide packets by NTU sizes. If the NIC hardware can support this feature, it'll be enabled by default, and you don't have to do anything. You can manually enable it at the virtual machine level. Jumbo frames is another way to get a lot of data out through the network quickly. The E1000, E1000E, VMX2, or VNX3 support these jumbo frames. As with any networking knowledge, the bigger the packet is, the more data will be sent through, the less overhead overall. Smaller packets cause more overhead and slow down traffic. So if you are able to transmit huge or jumbo frames, that would be more ideal. But of course, the physical devices have to be able to support this. It doesn't just work. There's also the split RX mode, using multiple physical CPUs to process the network packets. It can be used if a VM is receiving a lot of multicast traffic from the same source. It's supported only in version 3 of VMX.NET. It'll take effect when your NIC is heavily used or the NIC is receiving more than 10,000 broadcasts or multicast packets per second. As the RX, the TX mode allows separate threads to be created for a single flow to parallelize the VNIC and physical NIC processing. You can enable it per host using the command shown to use more threads to pass data through kernel layers. It's kind of the equivalent of adding another NIC so you can do more, you can send out more traffic at once. So here's a question. What networking features help to reduce CPU overhead used for network packet processing on the ESXi host? And the answer is those two. This second lesson is just like all the others from prior chapters where it focuses on ESXtop. There are a number of key points that you can look at to monitor network performance. Here are some listed. From looking at the physical switch to the virtual switch to the virtual NICs. Network performance will always depend on the application workload and the network configuration. The last thing you want is dropped network packets. If you start seeing that, that is bad news. ESXtop, of course, can show you a lot of the network statistics that you'll need. And here they are listed. The amount of data transmitted, received, average number of packets transmitted and received, the number of packets dropped, inbound and outbound. To display them, when you run ESXtop, enter N, and you'll see already by default some columns that relate to the earlier slide. Again, dropped network packets is something you do not want to see. This is bad news. Queues in both the physical NIC, the host, the virtual NIC, and the virtual host are limited. They're not infinite. So a problem of drop packets can be at any level. If the guest OS fails to retrieve packets quickly from the virtual NIC, this could be because of a high CPU utilization, or the guest OS is improperly configured. These are both easy fixes. If the host fails to retrieve packets quickly from the physical NIC, then it's usually because the CPU has high utilization. This can be more challenging. This is why you don't want to maximize the full use of your CPU, because you need some of that space to process networking. If things are being dropped by the physical NIC, then you know where the problem is. And this could be that the NIC may need another NIC to team up with to reduce the amount of load to each. It could be that the network infrastructure needs to get fixed. For example, maybe we need a new NIC that has a bigger buffer or can handle higher speeds. Could mean migrating some VMs that live on that NIC's host to another in order to minimize the traffic. In either case, you don't want dropped packets. Now, unexpected increases can happen. Those spikes, depend on a lot of factors. You could have a normal spike at the beginning of every workday as people log on. That's when you could have when you know you're going to have a bigger wave versus later on in the day. Nonetheless, you need to keep that in mind, that your backbone of your virtual network needs to have a high speed in order to manage these waves effectively, both to handle the client and handle all the traffic within. Once you start having traffic flow contend for network bandwidth, then performance can be affected. And that performance may not just be, the user's getting, it's taking longer for the user to log in. It could also affect things like storage if you're using network storage, or it could be hurting things like vMotion and other infrastructure that you'd need to have a nice clear way to transmit back and forth without any contentions. Some best practices: use VMXNet 3 adapters whenever possible in virtual machines. Use a physical network adapter that can support high performance features. Use team NICs together for load balancing. Use separate virtual switches, each connected to a separate physical NIC, in order to avoid any contention between the VM kernel and the virtual machines. If you have different speeds, then use network input-output control, and always ensure that there's sufficient CPU resources on the hosts to handle the workloads when and if you're going to deal with high network throughput. This week you have another lab where you'll monitor network performance between 3 different cases, like across physical network unlimited, across a limited physical network, and using the same port group with different, with the same NIC at all of them, but different switches. And as always, if you have any questions, feel free to ask away in Discord.